Hello, this is Geometry 9.4, and in 9.4 we'll be talking about the tangent ratio. The tangent ratio is part of trigonometry. Now, I know this class is geometry, but trigonometry has a lot to do with geometry, or the other way around as well. So trigonometry, the prefix there, tri. Trigonometry is just the study of triangles. Because if you recall, all of Chapter 9 deals with right triangles. And not only is the tangent ratio part of trigonometry, it's part of your trigonometric ratios. Even though we're just concentrating on one of your trigonometric ratios here today, the tangent ratio to be more specific, for any trig ratios, or they could also be referred to as trig functions, it's a ratio of two sides of a right triangle. And what you would always take a trig ratio of is one of the acute angles of your right triangle. So that's important to keep in mind, that you're just taking a trig ratio, whether it's the tangent or one of the other trig ratios that we'll go over in the next section, the sine or the cosine. But it's always of one of the acute angles of your right triangle. And then specifically for the tangent, and from here on out, we probably won't write the full word tangent. It's just tan. That's tangent. That's what's on your calculator as well. But you take the tangent of an acute angle of your right triangle. The tangent is defined to be the side opposite of that acute angle over or divided by the side adjacent, or that also means next to that acute angle of the right triangle. So that's the definition of the tangent, side opposite over the side adjacent. Let me give you an example here. Let's say I have a right triangle, ABC. Remember, if it's a right triangle, ABC, you always want to make the right angle C. Because then here's what I'm going to do, like we've done on other examples. Instead of side length BC, that's opposite angle A, so that's lowercase a. This is opposite angle B, lowercase b, and then the hypotenuse is C. And then a squared plus b squared equals c squared. You could use the Pythagorean theorem where c is the hypotenuse. That's why you specifically can make c the right angle. But the tangent of your angle, what we can take the tangent of in this right triangle is either the tangent of angle A or the tangent of angle B. Those are the acute angles of the right triangle. You don't take the tangent of angle C. But the tangent of angle A, here's how you write it, is equal to the side opposite that angle over the side adjacent. So here's angle A. The side opposite of angle A is side A. The side adjacent is next to, well, you might say, well, side C is next to angle A and side B is next to angle A. Do I just choose one of them? No. When we're talking about a side adjacent, I could have been a little bit more specific and said the leg adjacent, because C is the hypotenuse. That's what we'll always refer to as the hypotenuse, just the hypotenuse. So if we're talking about a side, whether it's opposite or adjacent, it's really one of the legs. Okay, so the side adjacent, that's the non-hypotenuse, is B. Tangent of angle A, this is the side opposite, this is the side adjacent. And we could also find the tangent of the other acute angle, the tangent of angle B. But now the tangent of angle B is the side opposite angle B. The side opposite angle B is lowercase b over the side adjacent. Again, that's the non-hypotenuse. So in this case, A. Those are the tangents of each of the acute angles of that right triangle.